Okay, in this video I'm going to show you an example of some IPv4 subnetting. And it says, given the IP address of 200.103.20, answer the following questions if the number of subnets created is 4. Well, with a 200 in the first octet, we know that's a class C. We might, in the margin, remind ourselves that class A's go from 0 to 127, class B's start at 128, class C's start at 192, and end at 223. Class D's and E's start at 224. And these are our special numbers: 0 plus 128, 128 plus 64, 64 plus 32. Okay, so this is a Class C network, and if we're dividing a Class C up into 4 subnets, that means S is 2, because 2 to the S is the number of subnets. And that means the mask is going to have two ones in the first 2 bit positions of the last octet. And 2 ones there is a 192, which is 128 plus 64. And so our subnet mask is easy to calculate: 255, 255, 255, 192. What this does is it gives me 8, 16, 24, plus 2 more, 26 ones in the subnet mask, and then 6 zeros at the end of it. So we've calculated the subnet mask based on the 4 subnets, giving us S equals 2. Now for a Class C, the first 3 octets are all network IDs, and so N is 24 for those first 3 bytes. If S is 2 and N is 24, then we can calculate H is 6, and the number of IPs per subnet is 2 to the H, where H is the number of host bits, the number of bits that label individual hosts in the subnets. 2 to the 6 is 64, so we have 64 hosts per subnet, or 64 IPs per subnet. If we subtract 2, we get 62 hosts per subnet. Make sure you distinguish between IPs per subnet and host addresses per subnet. And this 64 then becomes our increment, okay? And so we're going to label our subnets with their IDs. These are the subnet IDs, okay? And they're incrementing from 0, 64, 128, and 192. Basically what we're doing is we're taking an address space of size 256, which is the 8 bits from the Class C, and we're dividing it up into 4 chunks. Okay, so 256 divided by 4 is 64. And the first host address is 1 more than the network ID. The broadcast address is the last IP address there, which is 1 less than the IP address of the next subnet. And the last host address is 1 less than the broadcast. So I just filled in these numbers based on that. And the last one is always 255 in a Class C. Okay? So we used this sort of math with the N and the S and the H to calculate this. I've told you in the announcement to skip this part where it asks you to use the AND, bitwise AND method. We don't need that here because the bitwise AND method is used to find the subnet ID once you have an IP address somewhere in the range. And we don't have any IP addresses in the range. It also asks you to show your work to find the network addresses using the increment method. And basically I'm repeating the number of IPs per subnet, 2 to the H, and so 64 is our increment, and so the subnets are 0, 64, 128, 192. And it also notes here that if we look at this last byte, we've got 2 S bits and 6 H bits, okay? And there's a rule that says that the increment you use, and in incrementing from one subnet ID to the next, is the bit position of the least significant S bit, and this works here. This is the 128's place, that's the 64's place, and so the increment is 64, where we have this is the least significant S bit, okay? Hope that helps in solving this problem. Class C subnetting is something you want to certainly know how to do and be very adept at.